So now let's come to the PROFINET provider-consumer model again, that we can now understand also why in advance it works with standard Ethernet. Let's imagine we have a network here. We talked about automation. It's always an automation line. And in the automation line, now I have also created here a line interface. But it could also be a star. It could also be anything else. Doesn't matter. In the end, there is an individual frame sent from the controller to the device with the output information, and there is an individual frame, and unicast frame, as it is also called in the Ethernet, from the device with the input information, the current input information that are sent to the controller. And this is done cyclically. So let's imagine the connection is established, everything is there, communication is running. Then we have a cyclic communication, a cyclic data exchange of frames that are sent from the controller to the device and vice versa. Important is, do not answer. It's not like a bus system like Profibus, where the master in this case would have the token. And then if the master has a token, it polls each and every device. No, on Ethernet, we do this a little bit different. On Ethernet, we have a timing system inside of the controller and inside of the device. And this is the such called PROFINET update time. And so when update time is over, then the next frame will be sent by the device and by the controller without waiting for an answer of the device. We do not answer. And now the communication is established, everything is fine, everything is running. Now let's imagine that in the network in between here, whatever it is, the network, could be also a 5G network, whatever, then we have a network failure. May happen. So something is disturbed in the network, maybe a half-side broken cable, network overload, whatever it is. So that means in the end, both sides will not mention that there is a communication failure inside of the network. And it may happen that still from the one direction that the frames are coming in. That means we see here the frames from the controller to the device are still there. But no information is passed from the device to the controller. Because they are disturbed somehow, they are dropped in the network. Do not know why. Then the controller and the device does the same. The controller will check this because of here is no communication anymore, and it will inform the device that something is wrong with the communication. So it will identify that something is wrong, and it will also inform the partner and will send a PROFINET alarm to the partner and mark the communication as disturbed. Important is that we do not wait. So we send cyclic information from both sides, and the receiver of the information here, the receiver of the information recognizes if the communication is there or even not, both sides. That means each station is at the same time provider and consumer. So the PLC is the consumer of input information, while versus the device is the consumer of the output information from the controller, and vice versa. The PLC is the provider of output information, while versus the device is the provider of input information that are consumed by the controller. That's why this model here is working in both sides always. Now it could come the question, what happens if I have just output information? Then the back channel is kept empty, but also the empty channel is transported to ensure that the consumer provider model is working. So even if there is no productive data, then there is an empty channel provided by your development kit. It will be ensured. And so also then that data or that side of the party which does not contain real data, there will be let's say a monitoring of the devices possible. And so the device is going into safe state, the controller does the same, and then the connection is broken and needs to be re-established. So then afterwards, a complete new start of the communication is necessary and will be done automatically by the system. So in case of the maintenance guys fixes the device or fixes the failure in the network, then afterwards the connection will be re-established and restart again. And as mentioned, this is working in both directions, so it is independent if the connection is disturbed in the direction from the device to the controller or from the controller to the device, or in both directions, doesn't matter. So after the watchdog, then both devices will go into a safe state, and then the re-establishment of the connection has to be performed.